Hi guys. We're going to continue our discussion here about non-experiments and quasi-experiments. This is Will. He's going to help with this video. So in this video, we're going to talk about different ways that we can do non-experimental and quasi-experimental research. And in particular, we're going to highlight the difference between non-experiments and quasi-experiments and where they fall on the continuum between low and high internal validity. So let's get started. So your textbook has this chart. It's a lot. I know there's a lot of different designs in this chapter. Your textbook puts them into two categories based on whether they're comparing groups of people that already exist in the real world. We call those non-equivalent group designs, or whether they compare the same group of people over time. We call these pre-post designs. In the weeks to come, we're going to talk about true experiments, and we're going to differentiate between subjects experiments and within subjects experiments. So this sort of separation will follow what you'll learn in the future. In these videos, though, I wanted to really make it clear what is the difference between non-experiments and quasi-experiments. So we're going to talk first about non-experiments, and then we're going to talk about quasi-experiments. And in the next video, we're going to talk about developmental research. Okay, so let's get started with in the next video, we're going to talk about developmental research. So let's get started now about differential research designs. So this is a research study that compares pre-existing groups. The goal of this is to establish whether there's a difference between those pre-existing groups. Now, we haven't created the groups ourselves. There's no random assignment. So this kind of design is also called an ex post facto design. We're looking at difference after the fact. So I gave you some examples of this in the last video. Examples of these are when we're comparing kids with or without ADHD on their quality of sleep, or we're comparing dog owners versus non-dog owners on their happiness. So in both cases, we haven't decided, who has ADHD or who doesn't. These groups have created themselves in the real world. So in this kind of design, we'll measure our dependent variable. So in the case of dog owners versus non-dog owners, our dependent variable was their happiness. So we'll measure it in everybody in our group 1 versus group 2. We'll take an average of each group, and we'll look to see if there's a difference in the average scores between groups. So again, to emphasize, these groups were formed under circumstances that we as researchers cannot control. They created themselves in the real world. So as a result, do you think we can categorize this as a non-experiment or a quasi-experiment? What do you think? Why don't you pause the video here and see if we can figure that out? What do you think? Both? Fireman. Well, actually, it's a non-experiment. Can you say non-experiment? No. A non-experiment, because we as researchers didn't create our groups, so we didn't use random assignment to create our groups. We're going to be talking about this in weeks to come in the context of experiments. So we can't be sure that our groups are equivalent. In fact, they're non-equivalent. We're not even measuring all the different ways that they could differ that have nothing to do with having a dog. So because we're not measuring those other variables, we're not controlling for those, this is why we consider this a non-experiment. So for example, as I mentioned in the last video, dog owners might just have more free time and might be getting more exercise than non-dog owners. And this could be what's contributing to their happiness. And this has nothing to do with our question of whether it's having a dog or not that makes somebody happy. So this kind of design, differential group design, where we're not measuring other variables, we're not controlling for them, where we've got these non-equivalent groups, this is a non-experiment. So this is an example of something that we're going to learn about it more in weeks to come, called assignment bias. We want to avoid assignment bias if possible, because it interferes with our ability to establish a clear cause and effect explanation. Because of assignment bias, that there may be some bias in how people move into these different groups. Our groups might have different characteristics. They might differ in terms of other variables. And this is a real threat to our ability to say that it's the dog ownership that contributes to their happiness. So this is in contrast to true experiments that we're going to talk about in a few weeks, where we're taking a lot of steps to make sure that our groups are equivalent by thinking about who's going into each group. So I just want to emphasize, though, this doesn't mean that this kind of research shouldn't be done. No, it just means that we have to have a lot of caution and we have to be very conservative in the kind of conclusions that we draw from this kind of research. We have to acknowledge that other variables are likely at play and they could also be playing a role in our results. So in the scale between low to high internal validity, this kind of design falls pretty low in the internal validity. We could move it along the scale a little bit by thinking about those different variables that might also differentiate between groups and may contribute to somebody's happiness, for example. Measure how much exercise they get, measure how much free time they have, how much outdoor space they have, and make sure that groups are equivalent on those. And this, by measuring those other variables and matching our groups on that, we're moving it along the scale between low and high validity. Okay, so let's move on to the next video. William, you better go see where Julian is and tell him about that fire. Okay, because we're going to talk now, moving along, we're going to talk now about some other categories of this research. And I thought I would use some examples to illustrate these different designs. This comes from the research that I've been doing in collaboration with a group of scientists at Chys Hospital. This group of researchers have been working for over 30 years to better understand what are the core challenges that children who are struggling readers face, and how can we develop effective intervention programs that specifically target those weaknesses so that struggling readers can experience success. And they've been doing this now for 30 years. They've established a program that they call the Empower program that's commercially available. It's been implemented now into schools across Ontario, across Canada, and around the world. For example, the Hamilton Wentworth District School Board has been implementing this program for 15 years. The Niagara Catholic Board is now just adopting it. So I'm going to pose this question and show you different ways that we can go about answering this question using different experimental, non-experimental and quasi-experimental designs. So the question is, how does receiving evidence-based reading remediation help improve reading skills in children who are struggling to learn to read? In other words, what is the relationship between remediation and reading outcomes in grade 2 students? Well, we can answer this question in many different ways. We could compare the reading skills in grade 2 students who are struggling readers in schools that offer this program and test them at the end of having this program in June. And we can compare them to another group of children who are also struggling readers who are at a school that doesn't offer remediation and test them at the end of their grade 2 year. So for example, we could compare kids in Hamilton who receive Empower versus kids in the District of Niagara school boards who don't receive any intervention, and look to see how are their reading scores different at the end of grade 2. So this would be an example of what your textbook calls a post-test only non-equivalent control group design. Very complicated title, I know. The point here is that we've got two groups that exist in the real world. They're either in Hamilton or they're in Niagara. One group is getting an intervention. Another group is not receiving an intervention. We're not deciding who is going to which school. It's also called a static group comparison. And we're comparing both groups on their reading skills at the end of this time period. So that's why it's called a post-test. So what do you think? Is this a non-experiment or a quasi-experiment? In answering that question, I want you to think, what is the confound in this design? What are some other ways that kids in Hamilton versus Niagara, kids that get the intervention versus don't get the intervention, may differ that has nothing to do with their intervention? Why don't you pause the video here and see if you can think of that? What are some factors that can impact a child's reading skills that are independent of their intervention? Think about that now. Okay, well, hopefully you've come up with some ideas. I'm going to give you some more ideas to think about. Well, if they could be differing in factors that are related to their school. Maybe kids in Hamilton also have smaller class sizes than kids in Niagara. We know this is going to impact their learning and their reading skills. This, if we don't measure this and control for it, this could be a confound in the design. There's lots of ways that the kids could also differ. For example, they could differ in their social economic status, their ethnic background, intelligence, how many girls and boys are in each group. And in particular, one factor that we really need to measure is their reading skills at the beginning of intervention. If we don't measure this and control our groups on this at the start of intervention, then we'd have no way of knowing if it's the intervention that increased their skills or if they just differed to begin with. Okay, well, go find Julian, okay? I'm gonna be right back after I finish this video. Okay, love? Another difference is what we call the placebo effect. So it could just be the fact that they got any kind of special treatment. Doesn't even matter if it's the reading remediation that would benefit their reading skills because they feel, excited to have this extra opportunity to be in this special group. So if we don't control for these, we'd have no way of knowing if all of those factors is what improve their reading skills or if it's the intervention per se. And we really want to know this. We want to know if the intervention works. So this kind of design is called, we classify this as a non-experiment. It's pretty low in internal validity. It makes it hard for us to know that it's the intervention that's working. So the conclusions that we can draw from this study are, if we find a difference between groups, that children's reading skills are higher in the group that received intervention compared to those that didn't receive remediation, but we can't say that it's the remediation that's actually improving their skills. Okay, well, we can do this in another way. We can ask the same question, what is the relationship between reading remediation outcomes in grade 2 students? Sorry, what's the relationship between receiving remediation and their reading outcomes? We could do this by looking at just one group that receives intervention and comparing them before and after getting the intervention. This would be an example of what we call a pre-test, post-test design. Oh, thank you. Okay, come sit with me. So we have observations that are made over time for one group of participants, but we don't have a control group. So is this a non-experiment or quasi-experiment? What do you think, Will? Non-experiment or quasi-experiment?
Non-experiment.
Non-experiment, you are right. It's a non-experiment because there could be lots of ways that kids could change and differ between September and June that have nothing to do with the remediation. And without having a control group, we have no way of knowing if it is the remediation that improves their reading skills or if it's those other factors, right? Right. So what are those other factors? Well, we can call these time-related threats to internal validity. And we're going to learn a lot about those in the next few weeks. So for example, children might just have improved anyway, even without remediation. It might also be an example of practice effects. If we're testing their reading skills twice in September and June, well, maybe they're just getting better at doing the test and their improved scores have nothing to do with the remediation actually helping them. Also, we've also got this placebo effect problem. If we're only testing one group of children over time, maybe their reading skills improve again, just because they're in this special group, small group instruction, and it's really nothing to do with the intervention per se. So this kind of design, again, is an example of a non-experiment. We don't have a control group. Maybe it just wasn't possible for us to have a control group. That's okay. We just have to be honest about where we fall in the spectrum between low and high validity. This falls pretty low. And so again, we have to be cautious in our conclusions. We can say children's reading skills are higher after remediation than before remediation, but we can't say that it's because of the remediation that their skills improved. Okay, so how can we at least try to overcome some of these problems and move our arrow somewhere closer to high internal validity? How can we at least be a little bit more confident that this intervention is working at all? Well, we can do a quasi-experiment. I'm going to talk about 2 examples of that now. First is a time series design, and the second is called a pre-test, post-test, non-equivalent control group design. Let's talk about those now. So in a time series design, rather than just compare, so we're only testing one group of people. It's kind of like a pre-test, post-test idea. But rather than just testing them once in September and once in June, we make a series of observations before the intervention and a series of observations after the intervention. And the goal here is that we can look to see how is the data trending before, and look to see if intervention increases the learning so that it is more improvement than what would have happened before they received intervention. So now, because we can see what those trends are, we can be aware of them, we can possibly even control for them. So this is why it's considered a quasi-experiment rather than a non-experiment. So this is what it would look like. We would measure people in one group a bunch of times before they receive treatment and a bunch of times after they receive treatment to see if the increase they show in that time when they got treatment is greater than the increase they showed before. So this would inform our understanding of whether it's the treatment that produced the effect. I'm going to give you an example of some data that I've been working with somebody else from Chys, Dr. Jan Freiters. And we've been working in collaboration with the Hamilton Wentworth District School Board to see and evaluate the effectiveness of their implementation of this reading remediation program in their schools. So we got a big data set from almost 800 kids that are in grade 2 or grade 3 when they received the program. All of them were struggling readers before the intervention. They received a full year program. They had it every day, just about every day for an hour a day from the fall to the spring. And we look to see how their performance changes over time. We don't have a control group here because the school board thought it would be unethical, and I would agree, to only give this intervention program to some students, not other students. So we had to work with what we got. We wanted to still do a higher quality quasi-experiment. So we did a time series design to see how does intervention change the pattern of their reading growth. So here we have the results. So on this up and down y-axis, we've got scores from the developmental reading assessment. So every year teachers give this assessment to their students in the fall and in the spring. And we look to see how much did their reading skills improve in the years before they received intervention and compare that to the improvement they made during intervention. So what we can see is, yeah, every year their skills improved a little bit, but not very much. You can see that the slope of this change is rather flat. This is the year that they received intervention. You can see that the slope of this line is much steeper. Their improvement in the year that they received intervention was a lot greater than before. And you can see also that this greater improvement continued even up until grade 5. So this slope of this line is greater than the slope of this line. So the conclusion we can draw from this study is that there was a slow rate of learning before intervention, a faster rate of learning after intervention. Again, we can't say that remediation caused the scores to improve, but we've got evidence that it definitely was a contributing factor. Okay, the final quasi-experiment that I'm going to tell you about is called a pre-test, post-test, non-equivalent control group design. This is really what you want to aim for if possible. So in this kind of design, we've got one group who receives intervention. We measure them twice, before and after intervention. We've got a control group now who's measured again twice at around the same time when they either don't receive anything. So this would be a no treatment control group, or even better, if they receive some sort of other program, maybe it's a study skills program, and we can look to see how is the change in our treatment group different from the change in our alternative group. So we would test their reading skills in September and June in these two different groups. What do you think? Is this a non-experiment, a quasi-experiment, or an experiment? Well, I already told you it's a quasi-experiment, but why isn't it an experiment? Why don't you think about this for a second? Well, it's not a true experiment because we haven't randomly assigned people to either get the treatment or the control group. The schools are determining who is getting which program. And so it doesn't fall all the way high in internal validity, but it falls somewhere in the middle. And I'm going to show you an example of this from that group of sick kids when they used a quasi-experiment to address this question. This paper was, you can check it out, it was published in the Journal of Educational Psychology just a few years ago. And one of the co-authors is somebody from our department, Jan Freiters. So in this design, they recruited children that received intervention at their school and recruited another group of children who didn't receive intervention. They weren't able to randomly assign children to go to this school or that school. So again, that's why this is a quasi-experiment. But they tried their best to make sure that the groups were as equivalent as possible. So before the intervention period, they made sure that the students that they recruited were similar in terms of their age, gender, reading skill, intelligence, etc. So this is a table from that study. And you can see here is their intervention group. Here is their control group. They measured their age and made sure the groups were equivalent in it. They also measured their reading skills. The groups are equivalent in that. Intelligence, how easy it is for their attention to be distracted. So this gets at sort of ADHD traits, how their intelligence, their vocabulary, their speed of processing, how many children were males versus females, what their social economic status is. So they measured all of these variables and made sure in their recruitment that they have two as equivalent as possible groups. So this is why this is really a quasi-experiment. Then they measured their reading skills at the beginning and then at the end of the testing period. And here's the results. So what I'm showing you here is their scores at the end of intervention, controlling for their pre-intervention scores. So it's showing us the amount of change that each group made during this time period. And we're comparing our control group versus our treatment group. So you can see that the children that received intervention made larger change, significantly greater change than the group who didn't receive intervention. So the conclusions that we can draw from this study are that children that receive intervention show a greater improvement in their reading skills than children who do not receive intervention. We still can't say that intervention caused the change, but we're getting much closer. We can feel much more confident that intervention is playing an important role here. This is another way that we can graph this information. This is just sort of made up data, but gives you a picture of what we're showing here. So this here on the y-axis might be their reading skills in our two different groups, those that receive intervention versus those that don't receive intervention. And we would want to measure their reading skills in the beginning, make sure the groups are similar in that, so that we can feel more confident that if our intervention group increased, we want to see that that increase in scores is greater than what would have been experienced in the control group. So here's something for you to think about and a great way to check your understanding. I want you to ask yourself, why does adding a pre-test improve the internal validity of a non-experiment and make it become a quasi-experiment? What does it do to assignment bias? Okay, if you can answer those two questions, then I think that'd be a great way for you to check that you've understood all of this content. So in the next few weeks, we're going to be talking about true experiments where researchers assign participants to different groups or different conditions. The researchers in this way can control for any possible confounds due to third variables, due to directionality effects, due to assignment bias, and they can ensure that they're creating equivalent groups. They can also, unlike in this kind of design where we can't control the order of effects, in experiments, we can do things to control that order, which is a way to control for confounds that are due to time or maturation or practice. So on the scale between low and high internal validity, experiments fall really on the high side. So we're going to be talking about that over the next few weeks. So to summarize this video, non-experiments and quasi-experiments are often used in research designs where we're interested in more applied settings and we want to compare groups that already exist. These are not considered true experiments, again, because we're not creating the groups and we're not controlling factors that could contribute to our results. Quasi-experiments are what you should aim for if you are thinking of doing this kind of research for your research proposal, because they attempt to control for possible threats to internal validity. And so they're a better option whenever possible. And you should aim to do this in your research proposal, not a non-experiment. We talked about different kinds of non-experiments and quasi-experiments. We talked about ones that involve comparing different groups of people. And we talked about how assignment bias is a real threat whenever we're comparing groups of people. And researchers should be aware of this and acknowledge how this limits our ability to establish a cause and effect relationship. If whenever possible, when we're comparing two groups of people, if we can add a pre-test, this will highlight how groups might differ before they receive the treatment. And it's a step towards reducing this assignment bias and overcoming this threat to internal validity. We also talked about ways when we're comparing a group of people over time, and we talked about how a time series design is better. It's a quasi-experiment because it will allow us to be more aware of other factors that are related to time that might be impacting our results. So this moves us higher in the internal validity category. That's all for this video. We'll see you next time.